Hello everyone, welcome to my channel Chemical Engineering Knowledge. In this lecture we will discuss some multiple choice question of chemical reaction engineering. So the first one is the rate of homogeneous reaction depends on temperature, pressure, composition, all. So the rate of homogeneous reaction depends on temperature, yes. It depends on pressure, yes. It depends on composition, yes. It depends on all. So it depends on all. The rate of homogeneous reaction depends on all of the factor. The rate of resting reaction is very high. The rate of resting reaction is very high. It is very low rate. It is medium. None of them. So the rate of resting reaction is very slow. The rate of resting reaction is very slow. So it is very slow reaction. Similarly, neutralization reaction is very fast. The rate of neutralization reaction is very fast. In determining the rate of heterogeneous reaction, the heat transfer, mass transfer, both fluid flow play an important role. So, in order to determine the rate of heterogeneous reaction, the heat transfer play a very important role. Yes, the mass transfer play important role. Yes, so both heat and mass transfer. Suppose this is a catalyst particle, or suppose this is a cold particle. Suppose this is a cold particle. And suppose this is the surrounding air. So oxygen coming into the cold particle, it diffuse through the cold particle. Similarly, when it react with the cold particle, some of the heat produced and it come out from the surface of the cold particle to the surrounding air. So here both heat transfer and mass transfer are taking place. So it is a heterogeneous reaction. Suppose this is carbon plus oxygen, carbon dioxide. So this is a gas, and again this is a solid, and this is the gas. So this is the heterogeneous reaction. Similarly, in the reaction A converted into B, in this reaction the rate of A is in cubic meter cylinder, and 1 minute is change in mole of A per unit volume per unit change in time. It is equal to minus RA. Minus RA is equal to minus change in the mole of A per cubic meter into per unit time. So if it is 1 cubic meter volume and in 1 unit time, so the rate will be minus RA. Similarly, minus RA is equal to minus so this is not MCQs, so this is the correct one. A is converted into B. A is the number of mole of A. B is the number of mole of B. In this reaction, the unit of rate of reaction is mole of A per unit volume per unit time. So this is the rate of reaction is denoted by mole of A per unit volume per unit the time. Similarly, in the reaction A is converted into B. In this reaction, the rate of disappearance of A is given by. So the rate of disappearance of A is denoted by minus RA, which is equal to change in mole of A per unit volume into dt. RA is equal to dNA divided by V into dt. RA is equal to NV divided by V into dt. So it is not B, it is only about the component A. So the rate of disappearance of A is denoted by minus RA, which is equal to dNA divided by V into dt. So this option is correct option. A is converted into B. In this reaction, the rate of appearance of B will be denoted by plus RB. So this is not true. RA, it is not power A, it is power B. So plus RB is equal to dNV divided by V into dt. So this option is correct option. Molarity is defined as mole per unit volume, mole per cubic meter, mole per unit molecule divided by cubic length. All of these. So this cubic length is also a volume. So all of these are, and molecule is nothing but it is mole is nothing but it is number of molecule divided by Avogadro number. So also mole is mass by molecular mass of the component. So again this is the mole. So this is so molarity is defined as, so this option is correct. D. This option is similarly In the following reaction, A is converted into B. The rate graph of reactant A is. So the number of mole of A decreases with the passage of time, and the number of mole of B increases with the passage of time from this reaction. So the number of mole of A decreases with the passage of time. So the number of, in this is the number of mole of A increasing, the number of mole of A is constant. So which one is correct? This one is. The number of mole of A is decreasing with the passage of time. So this is the correct option. A is converted into B in a liquid phase reaction. In the above reaction, the rate graph of the product B is. So the rate graph or the mole graph of product B is. So the number of product molecule increases with the passage of time. It is constant with the passage of time. It is decreasing. So A is decreasing, and there is no constant. A is decreasing. So this is also wrong. So only the number of molecule of B increases with the passage of time from this reaction, and the number of molecule of A decreases with the passage of time from this reaction. A is converted to B for the above reaction. The rate law is given by. So the rate of disappearance of A is given by minus RA is equal to DNA divided by V into dt minus RA is equal to dCA by dt. So Na divided by V is nothing but it is Ca. Mole per unit volume is concentration or molarity. So this is a concentration, and this is the delta T minus Ra is equal to Kca. So this is also correct. So all of these are the correct. So the correct option is D. Rate of reactant A. Rate of disappearance of reactant A is denoted by. All of these options are correct. So D option is correct. A mole of reactant A plus B mole of reactant B give us C mole of product C plus D mole of product D. For the reaction, the relative rate of reaction of reactant A and B and the product C and D are given by. So minus RA divided by A, RB by B, RC by C, RD by minus D. So the correct option is minus RA divided by A minus RB divided by B, RC divided by C, RD by D. So this is option is correct option. For reactant, we will put minus sign and it will divide by the stoichiometric coefficient. This is the stoichiometric coefficient. So minus RA divided by A minus RB divided by B, and for the product we will write positive sign. So this is the RC, rate of product C, rate of formation of component C divided by the stoichiometric coefficient of the product C, rate of formation of product D divided by the stoichiometric coefficient of product D. But for the product we will write positive sign. So this one is the correct, and this is the wrong. This one is also wrong. Two mole of A plus 3 mole of B give us 4 mole of C into 5 mole of D. The relative rate of reaction is, again it is minus RA divided by 2 minus RB divided by 3 RC divided by 4 RDU divided by 5 minus RA and D. So this option is correct because minus RA rate of disappearance of A divided by the stoichiometric coefficient of A, rate of disappearance of B divided by the stoichiometric coefficient of B, rate of appearance of C divided by the stoichiometric coefficient of C, rate of appearance of D divided by the stoichiometric coefficient of D, rate of disappearance of A divided by the 3. So this is the stoichiometric coefficient of B, not of A. So this is the wrong. The rate of disappearance of A divided by 5. So this is the stoichiometric coefficient of 5, which is also wrong. Rate of disappearance of A divided by minus B. So there is plus. So it is wrong. A 1 over A 1 divided by 2 into A plus 1 into B give us C. The relative rate of this reaction is minus RA divided by 1 over 2 minus is equal to minus RB divided by 1 is equal to RC divided by 1. So the rate of disappearance of A divided by the stoichiometric coefficient, which is 1 over 2, and this is the rate of disappearance of B divided by 1 stoichiometric coefficient of B, rate of appearance of C divided by the stoichiometric coefficient. So this option is right one, and this is the wrong because it is 1 over 2, and this is not 1 or 2. So these are the wrong. This option is the correct option. Batch reactor are used for small scale production. Yes. It is for expensive. Yes. It is used for H's. Yes. It is used for explosive material. Yes. All of these are the correct option. In batch reactor, composition is same in bottom of the vessel, in middle, at the top, everywhere in the reactor. So composition is same everywhere in the batch reactor, but it changes with the passage of time. So as we increase the time, the conversion in the batch reactor will be increases. So it depends upon the time and the composition. At any time, the composition everywhere in the reactor is same. In flow reactor, there is non-mixing of fluid, not overtaking of fluid, both A and B, uniform composition of the material. In plug flow reactor, there is no non-mixing of the fluid. Yes, not overtaking of fluid. Yes, both A and B, uniform composition of material. So the composition changes with the length, time, and volume of the plug flow reactor, but there is non-mixing of the fluid and there is no overtaking. So the both A and B are the correct. A, B, and C are three reactor. A is batch reactor, B is CSTR, and C is plug flow. So this is the batch reactor. A is the batch reactor. A is the batch reactor, and B is the plug flow reactor. B is the plug flow reactor, PFR, and C is the CSTR. So this option is the correct option. In the ideal CSTR, the composition of the fluid, uh, the com the com the com the composition of fluid, mostly liquid, is same inside and at the exit of CSTR. Yes, inside and at the exit of CSTR, and at the exit of inlet and inlet, inside and in the inlet of the CSTR, inside and at the exit. So the composition is same at the inside and at the exit of the CSTR. Inside at the middle point of the CSTR, none of these. So these are the wrong. This one is the correct. Minus RA, rate of reaction, is a function of temperature composition is equal to KCA, where K is the rate constant, temperature dependent, concentration dependent, all A and B. So this K is the rate constant and it depends on the temperature. So both A and B are the correct option. Rate law for the below reaction is rate law minus RAK CA to the power N CB to the power M C to the power CBCC. So it is, this one is the correct. K depend on temperature and activation energy, kinetic energy, mechanical energy. K depend on temperature and the activation energy. It is from Arrhenius equation. K is equal to K naught E to the power minus E by RT. This is the activation energy and this is the temperature and this is the K. So K depends on the temperature and activation energy. A is converted into B. A is converted into B minus RA is equal to K to the power Ca to the power N. In this rate, the N show the order molecularity over all order, the mechanism. So N shows the order of reaction. Order of reaction can be determined by theoretical method from experiment both. So order of reaction can be obtained from experimental. Similarly, rate of reaction can only be obtained from experiment. Question number 44. 2A plus 3B give us 1 mole of C, 1 mole of D minus RaKCa to the power 2 Cb to the power 3. The overall order of this reaction is, so overall order of reaction is order with respect to A and order with respect to B. When we combine these two order, we will get us overall order. So overall order of the reaction is 5, not 2, 3, 1, 6, 1.5. These are wrong. 4 mole of 2 mole of A plus 4 mole of B give us 8 mole of C, 5 mole of D. 2, 4, 8, 5 in the above reaction show molecularity, order, mechanical, stoichiometric coefficient. So these are the stoichiometric coefficient. So 2, 4, 8, 5 are stoichiometric coefficient. If equation A show elementary reaction, if this equation shows elementary reaction, this is equation number A. If equation show the elementary reaction, then what will be the overall order of the reaction A? So the overall order of the reaction will be 2 plus 4, it will be 6. Overall order of the reaction will be 6. The order of reaction A with respect to A is the order of reaction in this equation. The order of reaction with respect to A, it is the second order with respect to A of reaction A. This is reaction A. The order of reaction with respect to A is 2, and the order of reaction A with respect to B is 4, and overall order is 6. 4 plus 2, 6. Minus Ra is equal to KCA to the power alpha, Cb to the power beta. Then the overall order of the reaction is alpha plus beta, alpha multiplied by beta, alpha divided by beta, beta divided by alpha. So overall order is alpha plus beta, as we have already discussed. This is alpha and this is beta. Alpha plus beta, which is gives 5. So overall order is alpha plus beta. Alpha and beta are any number. So overall order is alpha plus beta. Not these are wrong. Such reaction in which the rate equation corresponding to stoichiometric coefficient is called elementary, non-elementary addition. These are the elementary reaction in which the rate equation corresponding to the stoichiometric coefficient. These are the elementary reaction. So thank you very much. In the coming lecture we will discuss some more multiple choice question. If you are new to the channel, like and subscribe. Thank you very much.